In this video, we're going to practice all the derivative rules we've used up till this point, but mixed together within a single problem. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. So for this first problem, we have this function f of t, and we want to find the derivative. Now we have to ask ourselves, what derivative rules are we going to need? Well, here we're taking this quantity times this quantity. So one rule that we're going to need is product rule. But another rule that we're going to need is the fact that this function is being raised to the fourth power. So we have a function within a function. So this is going to require chain rule. Now different people will teach it differently, but the way I like to approach it is chain rule is just a part of the problem, whereas product rule is kind of an overview of the entire thing. So the way I'll approach this is we're going to start with product rule. So f prime of t equals, so first we take the derivative of t plus 2, which is 1, times, and we'll leave this quantity alone, t squared minus 3 to the fourth power, and to that we add t plus 2. Now here's where chain rule comes in, because now we have to say, well, what's the outside function? Well, it's being raised to the fourth. It's this quantity to the fourth power. So the derivative of that outside function is 4 times that same quantity, t squared minus 3, raised to the third power. But chain rule isn't done. We then have to say, what's the derivative of the inside? And so that's 2t. Now at this point, what we can do to simplify our answer is we can look and see what can we factor out. What terms do both of these have? And they both have a t squared minus 3. In fact, this one has 4 of them, this one has 3 of them. So that means we can factor out 3 of them. So we have t squared minus 3 raised to the third power. So when we factor this out of the first one, we're left with t squared minus 3. When we factor it out of this second term, we have t plus 2 times 4 times 2t. So now let's simplify this part a little bit. We still have t squared minus 3 to the third power, and then we have t squared minus 3 plus, so we have t times 4 times 2t, so that's going to be 8t squared. Then we have 2 times 4 times 2t, so that's going to be plus 16t. So now all we have to do is combine like terms. We still have the t squared minus 3 to the third, and so we have t squared and t squared, so 9t squared when we add them, plus the 16t, and then minus 3. So here's an example of us using product rule and chain rule. And really this is the faster way to do it, because you could expand this out, but the only way you could do that efficiently is if you had a computer algebra system to help you do it. Otherwise, this would be quite tedious. So let's look at the second one. Now, the second one requires the knowledge of e. So we need to know that, which we do. That's a pretty easy derivative, but this is a chain rule problem because that's built in. Because we want it to be e to the x normally, but it's not e to the x, it's e to the 2 over x. And since we're dividing, we also are going to need quotient rule. So our derivative dy dx, the derivative of e to anything is e to that, so 2 over x, times the derivative of this, and that's quotient rule. So that's low d high, so x times 0, minus high d low, minus 2 times 1, all over low, so x squared. So this is e to the quantity 2 over x times negative 2 over x squared So when we combine that as a single expression, we have negative 2 e to the 2 over x all over x squared. Now, an alternative way you could do this is you could think of 2 over x as 2 times x to the negative first. And if you did that, what would happen is you wouldn't need quotient rule. This would just be using power rule, and you would bypass this step and you would end up right here. So let's go on to number 3. Now, number 3 is phrased in a rather weird kind of way. We want to find the derivative of f of sine of x. Now we're not given f of sine of x, we're given f of t, and that is t cubed minus 4t squared. Well, we can write out what is f of sine of x, because all that requires is that we substitute sine of x in place of t. So we substitute sine of x, and that's cubed, minus 4 sine of x squared. Now what this is we want to take the derivative of this function, and that's going to be chain rule, because we have a function within a function. So our derivative is f prime of sine x is going to be equal to this term. Now that calls for chain rule. So we look at the outside function, and that's being cubed. So anything to the third power, that derivative is 3 times the base squared. And then we multiply by the derivative of the inside, which is cosine of x. Now, we take the derivative of sine of x quantity squared. The outside function is this quantity squared. So the derivative, now don't forget the 4. 4 is a coefficient, and that just hangs on for the ride. The derivative of the outside function is 2 times sine of x times cosine of x. That's the derivative of the inside. Now, to simplify this, we can factor out whatever these two terms have in common. They both have a cosine, and they both have a sine. So sine of x, cosine of x. And so now we say, well, what's left after we take out sine and take out cosine? That's 3 sine of x. And here, when we take out the sine of x and the cosine of x, all we're left with is negative 4 times 2. So that's minus 8. So this one required us to use chain rule by plugging in sine of x in place of t. Now, looking at number 4, here we have two quantities that are being multiplied, so this calls for product rule. But what's different about them is that which one is the inside function. Here, x squared is inside, and then sine is the outside function. Here, sine is the inside function because it's being squared. Now, in either case, chain rule is what we're going to be using. So, now the whole problem is a product rule problem. So, to help us, what I'm going to use is I'm going to use two different colors. I'm going to use red for this part. I'm going to use black for this part to remind us of what we're talking about. So f prime of x equals, now product rule says that we're going to take the derivative of the first part. Now I'm going to leave that blank for the moment. Don't know what it is just yet, but we'll get to it. Times, we're going to leave the second term alone, so that's sine squared of x plus, product rule then says we leave the first term alone, so that's sine of quantity x squared times the derivative of the second. Now again, I'm leaving that blank. So now I can say I've laid this out according to product rule, so I've taken care of that one. But now I need to worry about chain rule. So I look at chain rule for this first one. Now the outside function is sine, so the derivative is cosine of that, of x squared, and then we multiply by the derivative of the inside, times 2x. Now we're going to do the same thing for the derivative for the second part. So the outside function is this quantity squared. So that derivative, it's like x squared 2 times, but instead of x, it's sine of x times, and then the derivative of the inside, derivative of is cosine of x. Okay. And as we look at this, we ask what terms can be factored out of both. Here we have cosine x squared, here we have cosine x, not the same. Here we have sine squared of x, here we have sine x squared, not the same. Now we could factor out a 2, but it's almost a moot point. So for our purposes, we're just going to write this as 2x cosine of x squared times sine squared of x plus 2 times sine of x squared times sine of x times cosine of x. Since there's nothing else we can really factor out, that is our final answer for this one. Again, we did product rule, and then we came back a second time. I left the parentheses blank so that I could then do chain rule, So now moving on to number 5. Here, this one is just a very simple quotient rule along with trig rules. That is, we have sine that we need to find the derivative of. So dy, now again, pay attention because a lot of calculus problems from many different sources will try and trip you up by not having you use x. Instead, they'll give you s or t or some other variable. In this case, we have w, so it's dy dw. So, quotient rule says low d high, so sine of w. D high, the derivative of the top is 5, minus high, that's 5w, times the derivative of the bottom, which is cosine of w, all over low, low, so that's sine squared of w. It's being multiplied by itself. And as we look, the only thing that can be factored out of the top is a 5. And so we're left with sine of w minus w cosine of w all over sine squared of w. And that's as simple as we can make this. We've done the quotient rule, and we did the trig rule by taking the derivative of sine and leaving it as cosine. Now, one other possibility you could think of this is that instead of quotient rule, you could think of this as a product rule problem by taking 5w, and instead of dividing by sine, you can multiply by cosecant of w, because sine and cosecant are reciprocals. So instead of multiplying by this, or dividing by this, you multiply by that. And that has the same effect. And since we did talk about the derivatives of cosecant, we know how to do this one as well. Will the answer look exactly the same? No, but they will be equivalent. So looking at number 16, here we have two functions, sine of 12x, cosine of 12x. So that's product rule. And then we have inside, we don't have x. We have 12x, so that's chain rule. And then finally, we have sine and cosine, so that's trig rules. So our overall function is a product rule. We have this times that. So we have h prime of x. That's going to equal, so product rule says we take the derivative of this. So like a previous problem, we're going to leave that as red. We're going to leave that blank. And then we're going to multiply by the second part, which is cosine of 12x. Plus, and then we leave the first term alone, so sine of 12x times the derivative of cosine of 12x. So now we can go back and we can say the outside function here is sine. So when we do chain rule, we first take the derivative of sine, which is cosine of 12x. And then we multiply by the derivative of the inside, which is 12. Here, the derivative of cosine is negative sine, and that's 12x times 12. That's the derivative of the inside. So when we simplify this, we get 12 times cosine squared of 12x, because it's cosine of 12x times cosine of 12x. So it's cosine squared minus 12 sine squared of 12x. All right. Now, one other trig rule that we can use comes from pre-calculus, and that is if we factor out a 12, we're left with 12 times a quantity cosine squared of 12x minus sine squared of 12x. One of the trig identities was a double angle trig identity, and that says when you have cosine squared minus sine squared, what this is equal to is cosine of 2 times whatever the angle is, which is 24x. And so here's how you can simplify this. Now, one other way you can arrive at this is if you look back up here, this is very, very similar to another trig rule involving another double angle identity. When you have sine and cosine being multiplied by the same thing, that's equal to half that times sine of an angle that's twice as big, in this case 24x. Now what this does, if you write it this way, it removes product rule. And what you will end up having is just having to use chain rule and trig rules. But what you will get is the same answer as you did down here. So the way we simplified this and this up here are those double angle identities from trigonometry. And if you want, there should be a link in the description below to that video. So with number 7, here we have two functions, g of x, and it's equal to sine of k of x times f of x. Well, we don't know what f of x is, and k of x is just a number. Now let's look at this. Well, we've got two functions being multiplied, so this is product rule. And since sine is not of x, but of kx, that makes this chain rule. So those are the two rules that we have to operate on for this problem. So g of x, product rule says we first take the derivative of this. So the outside function of is sine, so its derivative is cosine of kx times k times f of x. So we took the derivative of the first, that's this part right here. And then we multiplied by f of x and we left it alone. Plus, then we leave the first factor alone, sine of kx times f prime of x. And unfortunately, not much we can do. I can move the k factor up front. K cosine of kx times f of x plus sine of kx times f prime of x. And unfortunately, since there's nothing else to simplify out, we can leave it like that. So moving on to the last one. Here we've got these two functions. They're being multiplied together, but this one is being divided. So that means we have product rule and quotient rule. All right. So here our variable is r. So our derivative dy is written as dy dr. So first we want to find the derivative of the first term. Well, that's pretty big, so I'm going to leave a big blank parentheses for that. Times, I'm going to leave the second one alone, 3r minus 6, plus, then I leave the first one alone, 2r minus 4 over 6 minus 7r, and then I take the derivative of the second one, which is 3, simple enough. So now I need to go back here. Now this is going to call for quotient rule. So, low d high, so 6 minus 7r times the derivative of the top, which is 2, minus high d low, which is 2r minus 4 times negative 7, all over 6 minus 7r, and that quantity is squared. All right, now let's simplify this numerator here. So we have 12 minus 14r. Now don't forget, this is negative, but we're also multiplying by a negative 7. So negative 2r times negative 7 is plus 14r minus negative, 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 so that makes it a negative 28, all over 6 minus 7r squared. All of that is still being multiplied by 3r minus 6. And so here we have 2r minus 4 over 6 minus 7r times 3. Now if we simplify the top, the minus 14r and the plus 14r cancel out, and then we have 12 minus 28. So if we subtract 12 from 28, that should be a negative 16 when that's left over. Negative 16 over 6 minus 7r, quantity squared, times 3r minus 6 plus 2r minus 4 over 6 minus 7r times 3. So now, what do we do? Well, one thing we can do is we can ask, what can we factor out of everything? Well, everything has a 6 minus 7r in the denominator. We've got one here, we've got one here, so we can factor that out. What else does everything have in common? Everything has a 3, because we can take a 3 out of this, and we can take a 3 out of that. And we can also take out a 2. We can take a 2 out of here, and we can take a 2 factor out of here. So, what's left of all this when we take out a 3 from here, a 2 from here, and a 6 minus 7r? We have negative 8 times r minus 2 over 6 minus 7r. That's what's left when we take all this out. Took a 2 out of here, a 3 out of here, and one of the 6 minus 7r's. Over here, we take the 3 out of here, take the 2 out of here, leaving r minus 2 all over 1. Now, what do you know? We can take one more thing out that we didn't see before. We can also take out an r minus 2. So r minus 2 over 6 minus 7r. So when we take out an r minus 2, we're left with negative 8 over 6 minus 7r plus 1. So now, to simplify this, one last bit is we need to combine these two using a common denominator. So we still have out front 6 r minus 2 over 6 minus 7r, negative 8 over 6 minus 7r plus, And instead of 1, we're going to write 6 minus 7r over 6 minus 7r. Now that we have the same denominator, we can combine them. So r minus 2 over 6 minus 7r times, and so we have negative 2 minus 7r over 6 minus 7r. And so at that point, can't simplify anything anymore, nothing else will cancel, and so that is our final answer. Now again, with these videos, there's so many different ways you can combine these, so please, if you have any suggestions or other problems you want to see worked out, please type a comment below and I'd be happy to work on them. If you like this video, please give it a thumbs up. For more videos like this, click that subscribe button. To support the channel, click on the Patreon link to help keep this going. Thanks so much for watching, and remember, the only way to understand something is to do it.